Welcome to this introduction to the load flow functionality in the Similix sketch tool. In the utility industry, it is key to have processes and tools for making solution design for new installations. The Similix sketch tool is a tool for creating sketches of future extensions to the grid. It enables project managers, engineers, and designers to express initial design considerations and requirements in quickly drawn sketches. When making sketches of extensions to the electric grid, it is important to assess the load flow in the proposed extension. What will be the resulting voltages at the consumption points? What will be the load on the conductors? And what is the power loss and the total power required for the extension? With the Similix sketch tool, you are getting a professional sketch tool where you can easily sketch grid extensions and immediately get an overview of the resulting load flow. Now, let's have a look at a simple example. I want to sketch an extension to the electric grid and evaluate the associated load flow. When selecting elements to sketch, I have the option to select attribute values for specifying more detail. When sketching a customer connection point, I can specify the required power to be delivered. When sketching an underground cable, I can specify the cross-section of the conductor and so forth. So now I'm doing the sketching. First thing is to define the locations where we must deliver the power. We need to deliver 5 kilowatt at these 3 locations, and we need to deliver 10 kilowatt at this location. The purple lines you see here is the as-built network, so I need to define where to hook into the existing grid. To do so, I take the source point and place it here at this location in the as-built grid. Then I sketch the wiring. I need a cabinet here and one here. And then I specify the 128 square millimeter underground cable to go from the source point to the first cabinet, a 64 square millimeter cable from the first cabinet to the second cabinet, and then 16 square millimeter underground cables from the cabinets to the 4 customer connection points. So now I have created the sketch and I want to see the resulting load flow. I open the load flow tab and here I get an immediate overview of the load flow at an overall level as well as at a detailed level. At the top you see the total required power for this extension as well as the calculated power losses. In this section below you see the resulting voltage and voltage drop at each of the customer connection points. And further below you have the current and the load percentage of each of the conductors. At the right hand side of the list you see a color indicating how well the sketched grid extension is dimensioned with respect to the load flow. For the endpoints, there are configurable threshold values for voltage drop. Green is for voltage drops below 2.5%, amber is for voltage drops between 2.5% and 5%, and red is for voltage drops above 5%. Likewise, for conductors where threshold values are defined based on load percent with respect to the ampacity of the conductor. Below 80% is green, between 80% and 100% is amber, and above 100% is red. I can also depict this coloring directly in the map. When this checkbox is activated, conductors and endpoints are highlighted in the map with the corresponding load flow colors. So you can see this red conductor with a load percentage of more than 130% is the one located here in the map. And likewise, I can select other elements in the list and have them highlighted in the map. The load flow calculation is extremely fast, which implies that it is conducted on the fly while doing the sketching. So, if I now go back to working on my sketch, you will see that the load flow colors of the sketched elements are automatically updated as I make changes to my sketch. If I remove this conductor, the coloring of the sketched elements are immediately changed to green, so I can see that this part of the sketched extension is okay from a load flow point of view. This endpoint is now gray because it is not connected to the grid. But if I add a conductor here, it also becomes green. I can continue to elaborate on my sketch and see how that will impact the load flow. So, to wrap up, with the Similix sketch tool, you are getting a professional sketching tool with load flow capabilities. This will enable you to include load flow assessment while doing the actual sketching, thus making the sketching process even more efficient. Thank you for watching this introduction to the load flow calculation in the Similix sketch tool. If you want to know more about Similix, the Similix sketch tool, or other Similix products, please do not hesitate to contact us.